transition from a large scale, well, somewhat a large scale cyber exercises running at the national scale down to a smaller, maybe even cheaper exercises. Well, maybe not entirely an exercise, a capture the flag. Please welcome on stage Pēteris Hermanis Osipovs, who is one of the core members for the Mārtiņa CTF. He's been also our partner for cyberchess CTF as well. Well, in general, he is a master student at University of Latvia. He will talk about building and running a CTF. So welcome him on stage with an applause.
So I think previously you should show the screen that I've connected via HDMI on this big screen, if possible. Technical issues? Perfect. So you want to host a CTF. I am Pēteris Hermanis Osipovs. I've finished bachelor studies in the University of Latvia in IT, still studying in master's. I've been part of the student council since my first course. I am a hacker at Netcracker, where I identify and help mitigate security risks in company products and services before delivery. If that sounds interesting, we have an open position in Riga. And I've hosted 5 CTFs, where mostly my duties were infrastructure, and I've learned Kubernetes while creating CTF infrastructure. So, while in the audience, I assume most of you already know what a CTF is. For those that don't, capture the flag, I would describe it as a hacker competition, where there are vulnerable systems that contain flags, but to access that flag, you need to hack the system. And so you hack the system, you give in the flag as proof that you've hacked it. And hopefully learned something in the process, learned what not to do in the industry. So for infrastructure, what are the requirements? Well, the bare minimum is a system that keeps track of users, the teams that the users are in, the tasks, start, end time, score, and challenges. Preferred is the minimum plus a system that allows you to have tasks running on containers or virtual machines that are isolated from between teams. So let's say that you have a task where you have an SQL injection. You probably don't want all teams to hack on the same machine, because if somebody registers their son Bobby drop tables, then the flag will disappear from the database. So the minimum is satisfied by CTFD, and for preferred is CTFD plus Nomakia or CTFD plus our own system. So CTFD, that is the default screen when you install it. Those of you who participated into cyberchess CTF probably recognize this screen. That is also CTFD, except with their own skin. It performs the basic functions of registering users, teams, tasks, start, end time, and it supports plugins. So if you know how to program in Python, then you're in luck, because you can modify it to suit your needs. What it does not offer is a built-in option to start tasks like containers, virtual machines, VMs, and all that. That's why we need a back-end system. For the first few years in Mārtiņa CTF 2023 and 2024, we use Nomakia, which performs really well at small scale. What it offers is isolated team networks, a VPN connection that can be either the normal one that you imagine, you just connect and you have an IP address, or level 2, where you can connect and you can actually perform ARP spoofing attacks and ARP spoofing plus man in the middle. So if you change your MAC address and IP address, the connection still remains. Container creation has a ready-made CTFD plugin. What it does not offer? It does not offer VM support, manual task restarting by users. So once you connect to the VM, to the VPN, this task is started, but if there is an issue in the container, well, first of all, you don't really see it in the front end. Second of all, there is no easy way to restart it. You have to talk to the organizers to say, hey, my task died. And yeah, it is not easily scalable across multiple host machines. You can run half the tasks on one server, half the tasks on another server, but that is not preferable scalability. And special thanks to Netgraph for creating and supporting on Discord. So, what are the requirements for our own system? Well, first of all, we require the ability to be hosted on one or multiple servers. Because in the previous years, our sponsors, well, they were renting server hardware from cloud providers. And for the first time, when you're renting, they told us that they don't give you the beefiest servers. You can get 3 less beefy servers, but you can't get 1 very beefy server. Second of all, obviously, VPNs for connecting to the team networks. We want some kind of way that the participants can access the tasks. And third, allow users to start, stop, or restart tasks. That is mainly coming back to previously. As I said, if a task is broken, they need a way to see that, hey, this is broken, the issue is not on my side, the issue is on the server side. And that can also be useful for specific tasks. So, for example, if you know when the container was started, and you know that the container, it's a cryptography task, where the exploit is, if you know the start time, you know the seed, and you know you can exploit it, then that is also useful for that. And a simple CI/CD to allow updates during runtime. Nomakia requires you to restart the whole system if you want to update something. And maybe later implement also the ability for not only in Git storing not only the configs for running the containers, but also describing how those containers associate with the tasks in CTFD. Still not implemented yet, sorry. So, question number 1. How do we host on one or multiple physical servers? Well, my answer is Kubernetes, in this case, a K3s cluster. Kubernetes is basically a container orchestrator. So if you have a task that has a front end and a back end, then the container running the front end is one thing, the container running the back end is another thing. Then Kubernetes, you can tell, OK, the participant has access to the front end. He does not have access to the back end. Then you tell through environment variables to the front end, hey, back end is at this IP address, or in Kubernetes case, internal DNS record. So yeah, Kubernetes API, it's an API that allows you to start, stop containers, create teams, get information about what is running on the cluster. And we use, well, I use Python to receive simple HTTP requests from the participant side. Well, in this case, CTFD. Then, for example, start task 1. Python looks it up in the database. Hey, task 1 needs these containers. They need to be connected in this way. That container has that as an environment variable, and so on. And then I use Kubernetes API library from Python to apply those policies to the cluster. So VPNs for connecting to the team network. Of course, there are many options for VPNs, but I chose to use OpenVPN for 2 reasons. First of all, Nomakia uses OpenVPN, and our Mārtiņa CTF veterans already are familiar with it, so they don't need to switch, relearn how to do things. And also, it comes built in with Kali. For creating it on our backend system side, we first create a namespace in Kubernetes, which is logical isolation. Logical isolation in a sense that you cannot have 2 pods with the exact same name, exact same parameters in the same namespace. So if we want to have the same challenge for 5 teams, if it all was in one namespace, well, we would have to add like team identifiers and so on, which is a bit problematic. Then we create a pod running a VPN server. Not a graph. It's just a VPN pod. Apply whitelist network policies. So for those of you who don't already know, in Kubernetes by default, any pod can talk to any pod, which is not preferable in a CTF competition. Then we register users within that pod and store their config in the database. Then we expose the pod to an unused external port. So by default, OpenVPN server uses port 119.4. And, well, we can't have multiple VPN pods inside the cluster and say on the outside of the cluster that, hey, just connect to this 119.4. So we expose it to, like, for example, for the first team, it is 31,001. And we rewrite it in the config, so when they connect to the cluster, the port gets forwarded to their correct container. And then we have a separate API that delivers the VPN configs from the database to the users. So you have a front end in CTFD. They click a button, get config. It adds their team name, username, calls the backend system. Backend system returns the config. CTFD, well, it's actually through web browser, just creates a file with that content that is returned. And users have a connection to anything within the namespace. So third, offer users to start, stop, and restart tasks. Again, Kubernetes API. Up here, you can see the post request that is actually being sent to our backend. It contains 2 variables. Team name, which is 1, because in CTFD, the team names, even if your name is Mārtiņš versus machine, then your ID in the database is still just a number. And the challenge name, that is the identifier used to understand what needs to be run on the cluster. So here they look it up in the database, a reversing task. Uppermost row is information that could be used for inserting the task in the CTFD. Second row is the pod container image, which contains the link to it, RAM limits, CPU limits, and if it is visible to the user. Then the next one contains environment variables, for example, in this case, flag, and it has the value of the flag. And then the last one is network, how it's defined. In this case, there's only one container, so it's connected to Teamnet. Teamnet, anything that is in that network, has the ability to talk to the VPN pod, or in layman's terms, the participants can access that pod. And then we see that these get applied as network policies to the cluster. Here we go, kubectl get all-n1, get everything from namespace 1. We see that a reversing task is running and the VPN container pod is running. And in the front end, those of you who participated in CyberChess CTF can see that the VPN pod IP is shown and the current running task status is shown. CI/CD, obviously the main goal is to reduce manual steps and make it easily accessible for anyone. We use YAMLs to describe each task. It contains the image build location relative to its location in the Git. So we have a Git, many directories. Each directory is a task. It contains a YAML, and that could contain subdirectories, for example, front end, back end, which contains a Docker file. And in the YAML, we just write /front-end. It knows to look in that directory. It builds the image and puts it in the private registry. So what the Python script does is git pull, iterate through directories, read the YAML files for each task, build the images, insert data into the database. To do is still implement the CTFD API, use the CTFD API to create these tasks actually on CTFD. And to update and fix containers during the CTF, well, if the container is broken, you can just push a new image to the registry and tell participants to restart the task. If some description is wrong, you can just update the task.yaml and push it and ask for somebody to run the update script. And we have a system for controlling tasks in the CTFs. What could be done differently? Choice is made 1. Yeah, that's a Roman numeral, that's not Shakespeare. In case of multiple K3S nodes, how do we handle VPNs and their traffic? So OpenVPN has a beautiful feature called failover, where you can write multiple server IP addresses and ports in the config. And for example, in this case, it's remote server 1, remote server 2, remote server 3. OpenVPN client reads this, tries to connect to server 1. If it fails, it jumps to server 2. If it fails, it jumps to server 3. What are the pros? Well, if one node completely dies, we already have the private keys and we can recreate it on another node. What are the cons? Well, if we want to add a new node, we need to update the client configs. So there is a whole mess of pushing the configs to the participants. We could use a separate node dedicated to hosting the VPNs. We just put all VPN containers on one node, connect the cluster internally with other nodes, and run the tasks on those. Well, for this solution, it's easy to manage VPNs because we know there's only going to be one VPN node. Tasks will probably be the most resource-intensive pods, so it should be easily scalable, especially if you have a memory leak in one of your tasks where a participant actually uploads a million checkboxes. The cons are, if the VPN node reaches its limit, it's pretty hard to scale, and all network traffic to the VPN node is doubled because everybody goes to the VPN node and everybody goes out of the VPN node. We could use a reverse HTTP proxy as well to split the VPN traffic. So we have one or multiple nodes that host HTTP proxies. We could write in configs that one.example.com is the reverse proxy name. When it reaches the reverse proxy, it knows, okay, team 1 is in this node. Why is this beautiful? Because if one node dies or is overwhelmed, we can just change the configs in the reverse proxy to redirect not to this node, but to another node. What are the cons? Well, HTTP proxies is network overhead. So we put traffic inside the VPN, and then we put it inside HTTP. And I think that this is resource intensive, although I have not tried this method yet. So Again, in case of multiple K3S nodes, we handle VPN traffic either by writing all node IP addresses, using separate node dedicated to hosting VPNs, or use a reverse proxy. Choice is made too. How do we describe and store tasks in the system? Do we simplify, as I previously mentioned, where we have a YAML file, and we just write everything in there, and to create a task, all you need to know is a bit of Docker, how Docker file works and how Docker containers are built. What are the cons? Well, it's quite limited, so if you have an idea for a task that requires to use all of Kubernetes possibilities, then you might hit a limit with that. Or we could actually allow just writing pod YAML files and replica set files and store them in the Git, and then just pull them, apply them where necessary. What are the cons? Well, in this case, it's easier to harden because we create a whitelist, we check, we verify. It's easier to create validity checks. In this case, we rely on task creators to not mess up because there is the tricky situation. It's a CTF. We want the systems to be vulnerable, but we don't want the infrastructure to be vulnerable. So some vulnerabilities could go a bit deeper than initially intended. So again, we can simplify, or we can specify YAML files to apply to the cluster. Decisions made. We chose to write all node IPs and configs because we can offload the load balancing to the users in that case, and also our CTF is not that big, so we are not expecting thousands of users. And we chose to simplify the YAMLs since when I say we, I mean Datoriti, who host Mārtiņa CTF, because we consist of enthusiastic students who know Docker. Some of us are very enthusiastic and love Kubernetes. Most of us, not so much. So, demo time. A little bit of hands-on, mainly terminals. I was told this is a tech crowd. So, I have a running system, and I'm just going to demonstrate quickly how it works. So, these are the API calls that CTFD would make to my backend system. In this case, team name is the team ID, username is the user ID. I can click send, and hopefully it will start working. Yep, here we go. Started team and user creation as a thread. Here we can see on the left is watch kubectl get all. So it is just describing the situation in the Kubernetes cluster. Here I have the SQL database. If I run this, oh, it already finished. Nice. So here we can see that up here is the job status, so to speak, because when you make an API call, it starts a job. And when you make another API call for the same team generation and user registration, well, we don't want to register them doubly accidentally. So if there is no entry in this, this table of the database, then we start it. If there is an entry in the database, then we just read it from the entry and return it to the client. This is translation from generic to internal IDs, and this is just the port that is used. And up higher a little bit is the VPN config. It's just a bit not for this screen. Of course, my fears came through, and the VPN config generation didn't work as intended. 1 second, I'll run it again, and hopefully this time it will work. So, yeah. So the fact that it's taking so long makes me think it is working slowly, because first it generates the VPN certificates. I made a mistake. I'm not that knowledgeable in cryptography. I have a friend in my team who is a crypto fan, and by crypto I mean cryptography, not cryptocurrency. And he told me that, yeah, you're using 248-bit keys, which is a bit overkill. So, will it work? Does it work? Supposedly it's finished. Why am I not seeing any action? Of course, my connection to the server has died for some reason.
Well, this is live demo, right? Just
of course.
When you're trying to fix this, just walk through the things that go through your mind as well, like why you're doing a particular thing when you're when you're fixing something.
Yes. So in this case, I'll assume that it is running on the cluster, but I don't have access to the cluster, but I have APIs. So team 5, I can see, so you see team name number 5. I generated team name 5, username 5. Get namespace, get all pods in a namespace. The fact that it's showing VPN container pod is running, that makes me think, okay, maybe it's working. I can try to get the user VPN config through here. If it is, well, working, then I can see, yes, it should be the correct one, because we can see that 31,005, since the team name is 5, it should be port number 5. So let's hope that it connects. Yes, initialization sequence completed. We have successfully generated a team. Now, okay, I'm connected to the network. What can I do? I have a get challenges API that shows me all the challenges that I can run. That is used by CTFD frontend to display the available challenges. I can try this challenge, needles in a haystack. Just have to send an API call, needles in a haystack. Team name is 5. Send. And to get the status, I can just resend this request, and I can see, hey, it's running. The reason why visible IP is 1, I also have implemented kind of an admin API where you can see invisible APIs, which are not shown to the common users. This task in specific has a VPN backend. But we can check if it is working. If I can ping it, I can ping it. I can run curl since it's a web task, and here we go. We can see the website. Somebody in the audience probably can already imagine what it looks like from HTML code. But yeah. And if I want to stop the challenge because the limit of challenges that I can run is reached, I can just send an API call to stop challenge. I get namespace. It is still showing as terminating because the front end has to know that, hey, this still hasn't finished yet, so that they can't just start a lot of tasks, stop a lot of tasks immediately. And that is pretty much it from the demo part. Thank you for your attention. This info will be available on GitHub after Mārtiņa CTF, which should be end of November, beginning of December. I'll probably post about it on LinkedIn, so if you want, there is a link to my LinkedIn. And this was my first time speaking at a conference, so special thanks to Bernhard for allowing me to be here. And do we have any questions?
Sure, let's take the questions from the audience, if there is any. If there's none, okay, for now. Let's warm up. Maybe the people will start generating questions. I'm also checking the Menti as well, so you can post your questions online. I will try to assess them as well and ask them. Now, Pēteris, you and your team have been engaged in assisting the CyberChess CTF as well, working together with the Hackfest. Can you just give the highlights of how easy it was to integrate? What were the challenges? What did you have to solve that hasn't been solved before to make this happen?
So first of all, I'm really happy that Hackfest is also using CTFD. So it was really easy. I have a CTFD instance on my own. I have a plugin. I just tell them, hey, can you git pull, push the plugin on your side? I see it. OK, it's working. Well, OK, there were some niche issues, but we fixed it. It was really easy. Also, they are extremely knowledgeable and forthcoming. So it was a really great experience to host a CTF with somebody who's done it for years and years and years. From our side, we needed to create the infra. And we faced an issue, well, I faced an issue that I hadn't faced previously. My highlight from CyberChess CTF was I thought that the limit for our infra is the /24 network. Theoretically, 255 IP addresses, some are reserved, roughly 250 IP addresses. I thought we were going to run out of IP addresses. Apparently, Kubernetes by default sets the amount of maximum pods that you can run. And to change that, you need to restart the cluster, which was a fun experience.
So what did the Hackfest team learn? Because I know that they learned something from you as well.
Well, we exchanged experiences because, of course, they're using CTFD, we're using CTFD, we're doing it as students, they're doing it as professionals. And it's just, in general, how do I put this? the difference in experience and knowledge, because we are still mostly students, and they are mostly industry professionals. So how we look at things, how they look at things, it's just a beautiful chance to see the world from a different view.
All right, if there's still anyone that wants to ask the questions, now your time. Furthermore, I mean, you're running this challenges, the Mārtiņa CTF, and offering a CTF already for some time. So how often do you do this, and what is your target audience, and how big is your target audience usually?
So Mārtiņa CTF, the first one happened in 2023, November. We had now roughly 80 participants, which actually was a big surprise for me. I thought like 30 people max. No, 80 people came to our CTF, and in person, it was beautiful. Then in 2024, we had a second Mārtiņa CTF. Already, I saw people from all around, from across Latvia, but we also saw some from Estonia, some from Lithuania. We had the team from Denmark. Yeah, 170 participants altogether. And after that, we started the University Cybersecurity Club, where we host our own mini CTFs, which I mainly use for testing infrastructure. So we had one in this year of April and this year of September that we did like the general mēģinājums, the huge test before cyberchess for our infrastructure.
All right, I do not see any hands being raised for now. Let's give a round of applause to one of the core developers of Mārtiņa CTF. Do you have a name of Mārtiņš as well? Because I know everyone has a name of Mārtiņš at the Mārtiņa CTF.
Well, since we decided that in the first CTF, well, of course it was a temporary name, and as we all know, temporary solutions that don't break become permanent solutions. So I was in that meeting where we decided we're going to be Mārtiņi. I got lucky. I'm Mārtiņš 1337.
Good choice. So thanks once again, and I'm so happy that we have such brilliant students in our universities. Thank you.
Thank you.
Well, wait.
Yeah. Oh.
A pair of socks for you.
Oh, thank you. I hope we won't be needing a sock for our CTFs.